Have you ever wondered if we are truly seeing the entire universe? Or is there an enormous part of it, hidden, beyond the reach of our senses? Today, we embark on a mesmerizing journey to explore one of the greatest mysteries of all time: dark matter. Dark matter, a term that may sound familiar, holds secrets that have puzzled scientists for decades. We know that only about 5% of the universe is made up of ordinary matter, the stuff we can see, feel, and live with. The remaining 95% is an unseen treasure, a substance that neither emits nor reflects light, invisible to our eyes. In this video, we will focus on this elusive element, dark matter, and uncover how it shapes the entire cosmos. Imagine that with only 5% of what we know, how could the universe have formed such magnificent galaxies and sparkling clusters of stars? The answer lies in the invisible hand, dark matter, which controls everything. But how can we know it exists if it shows no signs of light or energy? The answer is hidden in the subtle clues of gravitational forces, the relentless motion of stars, and the overall structure of the universe we inhabit. In the upcoming segments, we'll delve into the scientific evidence left behind by the universe, from the mysterious behavior of rotating galaxies to unsolved cases like the Bullet Cluster. We'll explore various hypotheses, from WIMPs to more exotic candidates, and review experiments conducted worldwide, from underground detectors to massive particle accelerators. Finally, we'll even imagine a universe without dark matter. Would it be an empty, cold, and lifeless expanse? Join me as we begin this journey, where every clue unveils another piece of the cosmic puzzle. You may never see dark matter directly, but through today's story, I hope you'll feel the power and wonder of an invisible entity that governs the cosmos. Imagine the universe as a gigantic pizza. You can clearly see the toppings, the stars, planets, and luminous clouds of gas that we observe. But the thick, hidden crust beneath is dark matter, the unseen component that our eyes cannot detect. Modern scientific studies reveal that only about 5% of the universe is composed of ordinary matter. The remaining is astounding: 27% dark matter and 68% dark energy. Altogether, 95% of the cosmos is invisible. If we only relied on what we see, we might think the universe is merely a collection of glittering stars and galaxies. In truth, a powerful, unseen force binds and shapes the universe. One of modern science's biggest questions is, how can such a huge part of the universe be completely invisible? Scientists have proposed countless hypotheses and conducted numerous experiments in search of clues to this hidden presence. Models from the Big Bang to galaxy formation all indicate that without dark matter, the universe as we know it could not have formed. Without dark matter, galaxies would lack the feet to stand firm, and the distribution of matter across space would be entirely different. Travel back about 13.8 billion years to the dawn of the universe. After the colossal Big Bang, the universe was a chaotic sea of plasma, where everything was intertwined. As it gradually cooled, fundamental particles began to form, and from the very first moments, dark matter emerged, silently laying the foundation for a modern metropolis of galaxies. Thanks to dark matter, clouds of gas later coalesced into the brilliant galaxies we see today. But how do we know dark matter exists if it shows no trace of light? The answer lies in indirect evidence, the subtle motions, the invisible gravitational pull it exerts. Every clue opens a new door of curiosity, revealing more of the enigma that is our universe. In a universe so vast, there are motions so peculiar that even classical physics is left in awe. In 1970, American astronomer Vera Rubin, along with her colleague Kent Ford, discovered a strange phenomenon in the rotation of galaxies. According to Newton's laws, stars at the outskirts of a galaxy, where the gravitational pull weakens, should rotate slower than those near the center. Instead, they rotate at nearly constant speeds, sometimes even faster. Rubin's groundbreaking observations raised a monumental question. What keeps these stars spinning so rapidly? If only visible matter were present, these galaxies wouldn't be able to maintain their structure and might even disintegrate. Thus, scientists hypothesized the existence of a massive amount of missing mass, dark matter, exerting gravitational force to hold the galaxies together. Not only in individual galaxies, but in large clusters such as the Bullet Cluster. Researchers discovered that the gravitational center does not coincide with the visible luminous galaxies. Instead, it lies in an invisible region that only dark matter could explain, evidenced by X-ray emissions and gravitational lensing effects that bend light from distant sources. Imagine the universe presenting us with a mystery unsolved, each observational clue a piece of a grand puzzle. And every piece indicates that there is a highly sophisticated suspect, dark matter, silently orchestrating the cosmic dance. But what is dark matter? Where does it come from? And can we finally catch this invisible culprit? In the next segment, we'll dive deeper into the modern hypotheses on the nature of dark matter, from traditional WIMPs to exotic candidates. Every sign of dark matter's presence reinforces that it is more than just missing mass. It is the very framework of the universe. Both simulations and observations show that dark matter weaves a complex network known as the cosmic web, a series of dark strands connecting galaxies and clusters. Without this network, the stars and galaxies we know could not have formed or would be scattered randomly, and the universe would be chaotic. Imagine the universe in its infancy, just a few 100 million years after the Big Bang. Ordinary matter, protons and electrons, began to coalesce into delicate clouds. However, dark matter, interacting only through gravity and unaffected by radiation, rapidly bulked up, forming dense regions that acted like the foundations for galaxies. Another key phenomenon that allows us to see dark matter is gravitational lensing. When light from distant sources passes through regions rich in dark matter, it bends, revealing the hidden mass that causes this distortion. Such clues confirm that the dark matter web is indispensable in shaping the overall structure of the cosmos. Recall the dramatic scene of the Bullet Cluster, where two galaxy clusters collided, creating a spectacular cosmic event. In this collision, the visible hot gas slowed down, while the dark matter, which does not interact in the same way, remained distinct. This clear separation is living proof that an unseen force, dark matter, is fundamentally structuring our universe. Every clue we uncover is like a step deeper into an extraordinary adventure, revealing how dark matter, though invisible, is the master architect of the cosmos. Dark matter is not merely a numerical placeholder in our cosmic models. It is a riveting cosmic detective story, where various suspects compete for the title of the unseen culprit. First, we have the WIMPs, weakly interacting massive particles, hypothesized heavy particles that interact so weakly that they have eluded direct detection so far. Next are axions, extremely light particles that might exist in such vast numbers as to contribute significantly to the universe's mass. Other candidates include sterile neutrinos, elusive particles that stray from conventional interactions, and even primordial black holes, tiny child remnants born immediately after the Big Bang, that might contribute to the hidden mass. Imagine facing a lineup of suspects in an unsolved case. Each candidate has its own unique characteristics. WIMPs, heavy, low-energy particles that are exceedingly hard to catch. Axions, lighter, yet possibly abundant enough to accumulate a significant mass. Sterile neutrinos, mysterious particles that avoid common interactions. Primordial black holes, not particles in the traditional sense, but potential contributors to the universe's hidden mass. Experiments around the globe are diligently hunting for these elusive particles. Underground detectors like LUX Zeppelin are engineered to operate in near-perfect isolation, aiming to capture the faint whispers of dark matter. So far, the signals have been mere hints, as if we are engaged in a high-stakes game of hide-and-seek with an invisible adversary. The allure of these hypotheses lies in their uncertainty, a suspenseful narrative that keeps us on the edge of discovery. Dark matter is not just a theoretical concept. It is an ongoing mystery, a quest that challenges the very frontiers of modern science. Will any of these suspects finally be captured in upcoming experiments? Only time and further technological advances will tell. From deep underground labs to the far reaches of space, humanity is relentlessly pursuing evidence of dark matter's existence. Scientists place their trust not only in theory, but also in daring, innovative experiments. Around the world, numerous projects have been launched to capture these elusive particles. In the depths of underground labs, experiments like LUX Zeppelin are designed to isolate every potential signal, listening intently for the faint echoes of dark matter. Imagine being in a silent, dark room where only the steady heartbeat of dedicated researchers fills the air, all in pursuit of the subtlest whisper from the cosmos. Meanwhile, at CERN, the European Organization for Nuclear Research, massive particle accelerators such as the Large Hadron Collider, LHC, recreate conditions similar to those moments after the Big Bang. Their goal is to produce and detect particles that might have the properties of dark matter. Simultaneously, the Alpha Magnetic Spectrometer, AMS-02, aboard the International Space Station continuously gathers data from cosmic rays, searching for evidence of dark matter particles streaming through space. Each experiment is a bold, challenging expedition, a testament to human ingenuity and determination. Years of hard work in extreme conditions all aim toward a single goal: to finally hear that elusive whisper from the universe. Every time a potential signal is recorded, the scientific community holds its breath, knowing that even the smallest hint could unlock a new chapter in our understanding of the cosmos. These experiments not only bring us closer to unveiling dark matter's true nature, but also open new horizons in nuclear physics and cosmology. The promise is that soon, with further advancements, we may finally capture these elusive particles, the missing pieces of our cosmic puzzle. Yet, a lingering question remains. If dark matter truly exists, what role did it play in shaping the universe? And without it, would our universe be a chaotic, unstructured mess? In the next section, we will envision a cosmos devoid of dark matter and appreciate more deeply the essential role it plays in our existence. Imagine a universe without dark matter, a cosmos where galaxies lack the feet to stand, and stars are merely isolated specks of light scattered in an empty expanse. With only 5% ordinary matter, how would our universe appear? Scientists believe that without dark matter, the universe would be chaotic, without the necessary links and structures. Galaxies, once radiant islands amid the cosmic ocean, would be unable to hold together, drifting apart over time. Picture a giant jigsaw puzzle with only a few pieces. No matter how hard you try, you end up with a disordered mess, missing a coherent picture. It is precisely dark matter, the invisible architect, that arranges the pieces of the universe into a well-ordered, harmonious whole, forming galaxies, star clusters, and an intricate cosmic network. Dark matter not only facilitates the formation of galaxies, but also dictates their evolution. It creates a map for the cosmos, enabling ordinary matter to coalesce into stars, planets, and eventually life. Without it, the universe would not only be chaotic, but lifeless. Take a moment to imagine a universe devoid of dark matter, where the splendor of galaxies and the brilliance of star clusters are nowhere to be found, replaced by empty, cold voids. The existence of dark matter imbues the universe with structure, meaning, and even a kind of soul. Though we may not recognize it at first glance, dark matter is the fundamental ingredient that defines the cosmos. It is the missing puzzle piece in the grand picture of existence, allowing scientists to build modern models of the universe and explain the formation and evolution of galaxies with clarity and inspiration. Now, let us move into the final chapter of our journey, a look at the future prospects and challenges in the exploration of dark matter. Despite decades of research, the true nature of dark matter remains elusive. Yet, it is precisely this uncertainty that fuels new breakthroughs and inspires future endeavors. From Vera Rubin's early observations to the striking evidence from the Bullet Cluster and numerous experiments worldwide, we have come a long way in understanding that the universe is not merely what our eyes can see. Dark matter, though invisible, possesses the power to shape the cosmos. It has been, is, and will continue to be a source of profound inspiration for scientific discovery. Global research initiatives, such as the James Webb Space Telescope, the Vera C. Rubin Observatory, and many cutting-edge experiments, are set to listen more clearly to the cosmic whispers of dark matter. In the coming years, we may receive breakthrough data, evidence not only confirming dark matter's existence, but also revealing its deep-rooted secrets regarding its origin and function. The future of dark matter research is not just a scientific pursuit. It is a story of human curiosity and passion for the unknown. Once we fully understand dark matter, we might finally unravel many other mysteries of the universe, paving the way for new theories about the cosmos, the origins of life, and even the meaning of existence. Remember, everything we see, the twinkling stars, mysterious galaxies, and even our own planet, is decorated by the subtle touch of dark matter. Like a master artist working in the shadows, dark matter paints a vibrant, meaningful portrait of the universe. The cosmos is a grand story, and we are only at the beginning of reading its pages. Let your curiosity and passion for exploration guide you, for every day, new clues about dark matter are revealed, bringing hope and new discoveries. Perhaps we will never completely solve every mystery, but it is the journey of inquiry that gives science its true value. If you are passionate about science and endlessly curious about the unknown, join us in following the latest updates, breakthrough discoveries, and pioneering advances in dark matter research. Subscribe to our channel and let's continue this quest together. A quest to decode the secrets of the universe, where truth hides in every ray of light that pierces the darkness. Thank you for joining us on this journey from the earliest clues to the promising horizons ahead. Though you may never see dark matter directly, with every discovery and every theory, we come closer to understanding the very essence of the cosmos. And perhaps, one day, the mysteries of dark matter will be unveiled, opening a new chapter for science and humanity.